we have seen user through mobile or uh, maybe web browser client, they try to access the services that is provided with the help of web server or databases. And we have seen that database is also a critical component where we have a master database, we have a slave database, whatever write request that goes to master and whatever read requests are that goes to slave. And we have also seen that there are multiple slave databases we can create so that the read requests, because always there is a ratio of write to read. Mostly people, those who are trying to access the web services, they are mostly reader. They don't write. But again, it depends on which system you're designing. If your system like YouTube, mostly people try to watch the video. They don't actually upload any videos. So these kind of systems will have more read request than the write request. So these kind of stuff, when these kind of systems, when you are designing, you will have a database. Maybe database is located on one particular machine. Maybe it's a EC2 instance or compute. And that kind of instance will have one database software, maybe MS SQL is installed in it. And it serves the purpose, like it serves whatever user requests are and try to uh, provide the required data. Okay, it gives the response according to the request. But the challenge here is, suppose, right, maybe initially you have thousands users, and for that maybe it is serving the purpose, like having one machine on which the database software is installed, and that is serving the purpose of responding to the user. And we have maybe two different servers. Maybe one is only for read, one is only for write, and the replication is happening in between. But just imagine if 1,000 users are becoming 10,000, a million, or 10 millions, something like that. This kind of architecture where you just have one particular database, which is on single machine, is not going to serve the purpose. It's not going to serve the millions of users. And there are multiple challenges. What if the server goes down? What if the data is so much that server cannot handle it? Like this database cannot handle it. Okay. Even the slave database's size has become smaller and smaller because the kind of huge data that is coming in. So in this case, what we can do, the first idea that is coming in our mind is do the vertical scaling, right? Wherever we have installed this database software, what we will do, we will increase the capacity. We'll increase the capacity of the machine itself. We'll increase the capacity of database itself, and even for the slave database, it's applicable to both. But again, as we have discussed earlier, vertical scaling also has a limit. How much RAM will increase? How much memory that we will increase? Hard disk space that will increase? So that has also has some kind of limitations. Maybe after some time that is also not valid, because the kind of request that you're getting, maybe you're getting thousands of requests per second. How to serve those requests? So that will be a challenge. And in that case, whenever your data, we cannot hold it on one single database or one single machine, then we have to divide your data or database into multiple machines or multiple databases. Okay, so that is where this important topic come into picture, that is called database sharding or partitioning. Okay, so we will look at it now, or both of these concepts, but this is to make your system available. Just imagine if your database is only on single machine or two machines, and the multiple requests are coming in. First of all, maybe you will get slower response because there's a lot of thing database has to do. And second thing, if machine has gone down, or maybe database wherever it is installed, that machine has gone down, that server has gone down, and in that case, again, the machine should get automatically restored, and then you should get the response. So there will be a lot of delay. So maybe database is not available, maybe there is a latency issue, and maybe there's a data loss also. And the main idea behind system design is to serve user as quickly as possible, so that our system is providing whatever is expected from that system itself. So this particular area, sharding and partitioning, is mainly for databases. And what we have seen just now, vertical scaling, when that is also not solve the problem, because the idea is the system should be available, it should be fault tolerance, it should have low latency. So all this we have to solve at database level. So that's why sharding and partitioning. So let's look at partitioning first. What does it mean? What is exactly purpose of partitioning? Okay. So what is partitioning? So there is a book definition. So it just says that it's a technique used to split a larger database into smaller chunk of partitions. See, database, in case of database partitioning, it's actually the data that we're talking about. not the whole database or not the database software that we're talking about, the data that is within that database. So it's a technique to split that data, which is in a larger database, into smaller pieces or smaller chunks. That is called partitions. And each partition is, we can store the data separately and we can access it separately. So that what if one database will have certain data, another database will have certain data. So it will improve the performance and you can scale it separately. Like one database stored on one machine, another database stored with the data on another machine. So you can scale it differently. Maybe we can increase the capacity of both the machines separately. So that separation is there and it improves the scalability. Okay. So what we are looking at here, I just prepared two different diagrams. First is horizontal partition. What does it mean? Just look at this diagram. Sorry. Just look at this diagram. First, this is the whole database in yellow color, left hand side, where we have user ID, name, address, country, status. I just put some data here. This is a user table. Okay. And maybe it has millions of rows. Okay. So in case of horizontal partitioning, what we do is we partition it horizontally. That means we partition by rows. Maybe some rows goes into one table and the rest of the rows, or maybe whatever partition we have, it will go to partition 2, partition 3. It depends on how many rows. Maybe I want 100 rows in one, or maybe 1,000, maybe 10,000 rows in one database. So I can split that by rows. So 10,000 rows, first 10,000 rows will go to one table, second will go to second partition, third will go to third partition, like 10,000, 20,000, this way I'm saying. So that will be an horizontal partition where we are splitting the rows itself, not the columns. So it is called horizontal partitioning. So you can see here, divides the table into multiple small tables, and each table separate the data store, and it contains same number of columns but fewer rows. This is what the definition that I mean. The problem with this kind of approach is that if the whole means the range that we are using, like as I mentioned just now, 10,000 rows for one table, we have to choose carefully, because the problem is maybe the algorithm that we use, maybe 10,000 here, 10,000 here, and maybe later on, if some more data that is coming, that will unbalance the server, the database server. It is not that user ID on which we will split, but there are multiple techniques that we'll use to split this data horizontally. That we'll look at it after maybe in a couple of seconds. We will just have a look at it, what techniques that we use. But just to make you sure that there are two ways we do partitioning. One is horizontal partitioning and another is vertical. Vertical is not different. Here we just split the data by columns, not by rows. So you can see the data has user ID, name and address, which is stored in one table, and then user ID. User ID is a primary key which is necessary to access the data. But the other columns, country and status, are different columns. So those will be stored in the another table, which is we can say an extended table. So this is how we do vertical partition. Again, here also definition that is given means some columns are moved to new table. So here we are splitting the column itself. Okay. And see this technique, mainly column. You may ask that why we need column and how if we will get, means how, what is the exactly use case of it. So it used to optimize the performance, because sometimes no, you don't need whole data. Maybe you just need to access name and address, or maybe order or order ID, or order information, maybe order price, something like that. That is not needed to read whole row of the data. It just need to read 2 or 3 columns. And that will be kind of most frequently accessed. Suppose I want order information. I just want who placed the order and what was the order amount, or what was the delivery. Delivery will be a separate table. So if I want to access 1 or 2 columns only, then this kind of use case will have these kind of database, will maybe this kind of partitioning, where you just need 2 columns or 3 columns and we'll create a separate table out of it. So that is the use case. And horizontal partitioning, where we need the whole row of data, where we'll do horizontal partitioning, and accordingly we will fetch the data. Okay, I hope this concept is clear. So let's move to the techniques or criteria on which we partition the databases. Okay, so this partition criteria, see, I have mentioned only 3. Maybe if you Google it, you will find more, but you will find these always there. Okay, but it depends on your choice of design, that how you want to partition. Okay, so there are 3 techniques in partitioning. One is range base, another is hash base, and next is round robin. So let's start with range base. So see here, we divide the data depend on the range that we decide, or range that we defined before we partition. So just imagine this, we have employee data. This is a database table where we are splitting the data by using a range called, suppose this range is from ID 1 to 25. Next is 26 to 50. This is the simplest example, but just to understand that we are first setting a range, that this is what a range from one for one table, and this is what the range for another table. And accordingly, the data will split. So whichever IDs that are coming between 1 to 25, that will put into one table, and second range data will put it in the second table. So this is a kind of range that you have to define. See, a range is not only apply to IDs, okay? Because I'm explaining with the ID, that's why you may think that it is only by ID. But here I'm given some examples. It may be an integer or longs, whichever column that has this. It may be a timestamp. I want to divide the table for a particular time. Maybe I want to divide by year 2021, 2022, 2023, something like that. It may be anything. It may be time also. I want to see the order that applies from morning 6 to uh, evening 6, and then later whatever time that I define. So it may be defined on any of these things, IDs available or timestamp available. But it is a choice that you have to make, that depend on the use case, what kind of uh, range that you have to decide. And accordingly, you can split this data. So that is a range, and the range you have to define prior to do the partitioning, and accordingly you can create the partition itself. But again, as I mentioned, it is not just with primary key. It may be with any column. You can decide the range. Okay. Moving to next, it is hash base partitioning. Here, it is nothing but you create a hash function in which right now I'm just passing the ID, but it can be anything, any one column or multiple columns that you can pass to this hash function. Here we are sending an ID to this hash function, and this hash function returns a partition number. This hash function can be anything. If you want to get into details of how exactly this is working, maybe we can look at it later. Maybe it's a mod function where you will get some value in the return. So that we'll look at it later. But at least just think about, there is a hash function in which you pass on one column, that is ID. You can also pass on multiple columns as well. And it returns you a partition ID. And according to this ID that is returned by this hash function, we send the data to the two different tables. For example, you see partition 1, partition 2. So because ID 1 has written, means when you pass it to hash function, it returned partition 1. That's why it went to partition 1 itself, the table which is in the partition 1. And then we sent ID 20, the hash function returned partition 2. So the data went to partition. I think there is something wrong here. It's supposed to be in partition 2, not in partition 1. Okay. So according to this partition, uh, that is written by the hash function, the data should goes to that particular table itself or partition itself. Okay. And last is round robin, which is, I think we have seen earlier. It's just sending the data in cyclic manner. First data will go to first table, second data will go to second partition, third will go to third partition, fourth will go to again. It's like one, how many partition you have, it will go in sequence. First data will first, second will be to second, third will be go to third, and then if partitions are ending, then again it will start with first. So it's a cycle. So according to that, but then it depends, means what kind of partition criteria that you want to use, it depends on system to system. You have to, maybe sometimes you have to try all and check whether which criteria is suitable for your case. And it may also, you have to see that over the period of time, how it is working and how it is returning the values to the user or the data to the user. And accordingly, you have to see that how it is performing, the whole system itself. Okay, so this is all about partitioning. And these partition techniques are used by in combination also, like maybe custom partitioning will be there where we are using multiple partitioning method to partition a data. See, so far we have seen that we have data that we are splitting. Data we are splitting into one table and second table. This is just an example. Maybe it will be hundreds of tables. There is a possibility, depend on the how many users do you have. But this partition is, maybe it is on the same machine itself. You have multiple tables in your SQL database or any other database. Okay, but there is another important topic called sharding. And when sharding come into picture, many time people use partitioning and sharding interchangeable. But there is a small difference between them. that we need to understand that what exactly partition is and what exactly sharding is, because partition is related to data. We are splitting the data, not the machines. Like as database stored on one single machine may have multiple partitions. So this is what I'm trying to define here. So let's just quickly look at what is data sharding, database sharding. Sorry, it is database sharding, not data sharding. It is a horizontal scaling of database. What does it mean? When we split the data across multiple database instance or shard. See here, again, it is just to improve the performance and scalability. But each server handles a portion of data called shard. Here we are talking about the data on multiple servers, multiple machines. That is called shard. Like each machine on which the data is stored is called shard. In partitioning, data is split, but it may be we kept it on one single machine. So that kind of, I know I'll take an example, but if it is not clear, that's why I have shown this diagram and all below. So I'll explain it, but just to make clear that data partitioning is the splitting of data. Database sharding is splitting the data across the machine. Okay. See, this strategy mainly again to make your database. First of all, if it's a single database, it's a single point of failure. Okay. So to make it more fault tolerance, what we are doing is splitting the data to multiple servers so that our data is fault tolerance. It will be replicated. There are multiple nodes available which is having similar data. If one node goes down, another node will take care of it. So all those things will be there. But to get that, you have to put it on a multiple machine. So this is the kind of horizontal scaling that we are doing, putting the data into multiple machines. Or maybe there will be replication also happening. So anything goes down, any server goes down, doesn't matter. Other server will take care of that request. Okay. So here in this example, see suppose you have a database of 100 GB and you have a partition that data into 5 mutually exclusive partitions. What does mutually exclusive means? You have 30 GB data, sorry, you have 100 GB data, you split it into this 30, 10, 20, 30, 10, this kind of partition that you created. The data that is available in this first partition, that is 30 GB, it is not same as 10, 20. So it is just that maybe first 30 GB of rows went into this partition, and then next 10 GB data store in the second, the next 20 GB data. So they are not similar. They are different data. They are not duplicate data. So that is the mutually exclusive term here. So we have split the 100 GB into multiple partitions, and each of these partitions stored on one database server also, or maybe means just imagine this all partition are stored on one server. Okay, and it may possible that maybe 30 and 10 we will store on one server, 20 we will store on another server, 30 and 10 again will store on another server. Maybe 3 servers are having these partitions. There is a possibility. Okay. So here again I'm trying to explain in detail. So it depends on how many shards. That means how many server you have on which you want to save your data or save your partition. So here again on the right hand side, just now what I explained, 30 and 20 GB data is went to shard 1, and next 10, 30, 10 GB data is we have stored on shard 2. Shard means again another service on which the database software is installed and your data is inserted into that database. So shard is nothing but a different server itself. So let's look at this partitioning chart that I prepared at the down. See, the columns are partitioned. We are talking about partitioning, and sharding is the rows. Suppose on a single database, we have not partitioned and we have not shard. This is no and no. So the first column, first row is talking about there is no partition, there is no sharding. That means it's a regular database. We have one single machine on which we have one single database, which usually we do it locally when we install SQL Server or something. We don't create any kind of partition. We just have one SQL Server database in which we just store our data. So that's a simpler case where, and this is the regular practice when we do locally. When we create a local database, we create table and we just insert the data into it. So this is the irregular case. But if you look at the second, like first column, second row, where we have not done partitioning, but we have done sharding. The yes means we have done sharding, no means we have not done the partitioning. What does it mean? There are two different servers with the same partitions. For example, this will be kind of, we have seen read replicas. We have just now seen the replica that we create. It is actually, the replica will have the same data like master database, right? So here we are not splitting the data. It's the same data copied to another server. So this is easier case, like this is easy to understand. It is a replica where we have not partitioned. We just split the data into two machines. We have created one machine and we have copied the same data into another machine. So machines different. That's why it is sharding is yes, because there are two different machines, but data is same. We have not partitioned. It's the same data we have copied to other. So that's why this is showing the same. See, the color that I have given is just to give an understanding that if it is partitioned, then the color is different. Right now, the red color that I've shown is just showing the partition. Whether the partition is similar, then it will be same color. And if there are two database symbols, that means sharding. I hope this is clear. If not, just let me know. But I'm trying to explain to you that so that it will be clear to you. Just think that sharding is two different machine, two different servers. Okay. In the right hand first row is partitioning is yes, but sharding is no. What does it mean? We have made the partitions, we have split the data, but it is on only one machine. It is possible that in a single SQL Server instance, you can create multiple partitions. It is possible for different use cases. You can do that. But that's a single machine on which database is installed and you have partitioned the data. So you can see red and green are two different partitions. Okay. And last is we have also partition and we have also sharded. So what we have done here is we have two different databases instance on two different machines, and we have stored one partition on one machine and another partition on another machine. So this is what the main use case for our topic, the entire topic that we are discussing. This is what we are trying to do here. Like we are splitting the data, like first by partitioning and second by putting the data on a different machines. And this may again, like see the combination also we can use. Maybe the green one will have its own another replica or maybe another passive database. The red one will also have another passive database so that failure can be taken care. So all those things will be there. I hope this is clear. Do you have any questions? No? So let's move ahead. So just to mention some benefit, again, as I mentioned earlier, we are looking for horizontal scaling. We want to see that adding more machine is important. As we have seen, horizontal scaling has no limitations. We can put multiple machines so that any request that are coming in, if the number of requests or traffic that is increasing according to the more machines will get added, and it will shorten the response time. The latency will be lower. Okay, so that is here the same points I mentioned. See, the reason why latency is uh, lower because more tables and user will be send it to the exact partition, exact shard uh, by looking at the which user is sending the request. Then accordingly, we will figure it out. Okay, which partition will have that data, and then which partition store in which shard. So accordingly, that request will be sent it to the correct server, and it will fetch the data. So response will be much quicker. Okay, but there are other drawbacks as well. Just imagine if you want to sort data or order data by certain way. I want to order by ID, I want to order by address, I want to order by country. But because the data is split across multiple database, multiple partition, that operation will be a difficult operation because you have to fetch the data from different shards and sort that data. It will be a kind of complex operation. It's not, I'm not saying that it is impossible, but it's kind of complex operation and it may take some time. Okay. And there's another chance that because data is stored on a multiple partition on multiple shards, there will be kind of uneven distribution of data possible. Depends on use case. You have to keep eye on where, like just imagine someone famous has tweeted something about uh, your website and suddenly the traffic has increased. Maybe people from India region suddenly started looking at your website or sending some queries or something like that is happening. And if you have partition data based on country, then the partition which has India uh, people data that is stored, that will shoot up. That will that's increase of that particular database will increase so much that you will not able to handle those. Then you have to partition the data into again multiple servers or maybe multiple shards, and you have to serve that. But you don't know this time. This kind of use cases are not that uh, famous for smaller applications, but it may possible that yes, it may happen that maybe sometime you will get sudden peak in the traffic itself, and then accordingly you have to serve the users. So those kind of rare, maybe your system will go down, then according to you have to make decision what should be done. And these are all kind of like trial and error. It's not that every time you can create a perfect system, but sometime it may go down, but that's the kind of learning, and then accordingly the system can be changed or redesigned, but it will be a costliest matter to design a system like that. But it again depend on, you have to, when you design a system, you have to decide on what kind of approach that you will take it. So this is about partitioning and sharding. There's one more topic that we have to look at it later on, that how exactly this request that are coming in from user will look at, okay, where exactly the partition where the data is stored. Like for this particular user data should go to which partition, and that partition is stored with which shard. How to find out that? See, this kind of algorithm we have seen just now here. It all depends on the range base, what range it is. Okay, which range is stored in on which partition, then this partition store on which shard. These are the algorithms that we use. Mainly, there's nothing but the same algorithms. Maybe there are some add-on to it. We will use the same algorithm, but we will see a practical case where how exactly it is working behind the scene. Okay. So I hope this is clear. Do you have any questions on partition and sharding? If not, then I'll stop sharing.